Okay, so good evening, guys. Hello. Hello, everyone. Just confirm if the audio is good. Okay. So, hello, guys. Welcome back. So in today's backlog session, the topic is going to be vectors. Okay. So, vectors is very important, even from the start itself, right? So, the first sections of physics that we are going to be studying, which is mechanics. So, everywhere in mechanics, we will definitely need vectors. Okay. So, vectors is an essential topic. But it is mainly a mathematics topic itself. So you can include this as a part of basic math itself. So vectors, you can just consider this as basic math itself, as a part of basic math itself. Okay. So today we are going to discuss the basics of vectors mainly. So we are going to cover the basics, and the basics will involve the representation and stuff. Okay. And then we are going to learn how to add vectors, how to add and subtract vectors. Okay, so the algebra of vectors. And then we are going to move on to dot product. Okay, dot product. And if we get the time to do it, then we'll also cover cross product. Okay, so cross product is the slightly confusing part. So if we get the time, we will cover that also. Okay, so okay. So good evening, everyone. My name is Gokul. Okay, Kirtan. Hi, Kirtan. Hello. All right. So I'll be not looking at the chat too much. Okay. So I'll be focused on taking the lecture. But you guys can definitely type your questions. Okay. I'll occasionally look at the chat. Okay. And answer your questions. Okay. So another thing is, guys, also while you're watching the lecture, keep writing with me. Okay. Write along with me. Write along with me. Okay, because vectors is a mainly mathematical topic, right? So you would also have to write things to understand. Okay, mathematics you can only understand by solving and writing. So you don't have to write the theory part, right? Because the theory part you guys can anyway get the notes, right, in your WhatsApp group. Okay, so I had a doubt. Can two non-zero vectors have a resultant equal to the magnitude of one of the vectors? If yes, derive the condition between their magnitudes and the angle between them. So Kirtan, we will get to vector addition. Okay, then I will take the doubt. Okay, then I will take your doubt. Okay. Okay, after, so I will take your doubt. Once we reach triangle of vector addition, in fact, it might be clear to you only. Okay, the answer is yes, you can. But let's start first. Okay, so we will start from the very beginning. So what exactly is a vector quantity? So before that, we will talk briefly about scalar quantities. Okay, so scalar quantities, most of you must have covered. It's any physical quantity which you can study just by looking at the magnitude. Okay, or basically you can understand everything about the quantity by just looking at the magnitude. So if I take a simple box, for example, okay, if I take a simple box for an example, and this box, you can measure this property known as the mass. Okay, you can measure the volume of the box. Okay, you can measure, so inside the box, let's say we have air present, so you can measure the temperature of the air. You can measure the temperature of the air. So in the units and dimension lecture, we learned that any physical quantity which you can measure, any quantity which you can measure comes under the category of physical quantities, right? So inside this, so for this box, mass is a physical quantity which we can measure. The volume of the box is also something we can measure. temperature is also something we can measure. But for these three quantities, there is a speciality. These are all represented simply using its magnitude, which means we will have a number and a unit. So mass, for example, is represented as 3 kilograms. Okay. There is no additional information we need for mass. Similarly, volume, we can represent it as 100 centimeter cube, right? Once again, only a number is required. And for temperature also, we can measure it in degrees Celsius. Okay. And nothing else is required. So quantities that come under this category, which are quantities that only need a number and a unit, or in simple words, we only need the magnitude of that quantity. Those quantities are classified as scalar quantities. Okay. So for these quantities, we only need the magnitude. So the examples of these are distance, mass, time, speed. So these quantities you have already learned from younger classes, right? Volume, temperature. So all of these are scalar quantities. The next thing is scalars add simply like numbers itself. So if there is the same box example, and inside the box, you added, let's say, 100 ml of water. Okay. And in second step, you added 300 ml of water. Okay. Then what is the total amount of fluid in the container? You will simply add them algebraically, right? We'll simply add these two like numbers. So 100 ml plus 300 ml. So in total, the fluid in the container, the total volume of fluid in the container will be 100 plus 300, right? Mass also is added exactly the same way. So this is the main idea behind scalars. Okay. Now there are some extra quantities. There are quantities in physics for which we also need additional information apart from the magnitude. Okay. For the scalars, we only need the magnitude, but there are also quantities for which we need additional information. Okay. So these quantities, we put it under the category of vectors. And what is that additional information? It is information regarding the direction. Okay. So if I take the box once again, and if I place it on the ground, so the best way to study vectors is using force and velocity. So we'll see this, sorry, force and displacement. So we will be using the force vector and the velocity vector and the displacement vector a lot in this lecture. So if I talk about the force, if this is a block of mass, I can apply the force in this way, right, at some angle. So let's say this angle is 30 degrees. And the force, let's give it some magnitude as well. Let's give it 30 Newton. Okay. The force, as you may already know, its SI unit is Newton, right? We covered it in the units and dimension part. So if I apply force at an angle of 30 degree, so in this case, it's like, it's not enough to only say that the force is 30 Newton. Okay. When we are applying a force, we also need to specify what is the angle in which the force is applied. So you can apply this 30 Newton force at a 30 degree angle, or you can apply the same 30 Newton force horizontally, right? You can pull the block in this direction. There are infinite directions in which you can apply this 30 Newton force. So from this example itself, it's clear that force should be classified as a vector quantity. Okay. Force should be classified as a vector. It should be classified as a vector quantity, right? Because the magnitude is not the only important factor. You also need the direction of this arrow, right? Because for the force, we need magnitude, which is how strong the force is, and the direction, which is in which direction is the force being applied. Okay, we need these two information. All right, great. So So the quantities that are first we are going to study is displacement, velocity, acceleration and force. So acceleration and velocity, mainly we will deal with them in kinematics, right? Motion in 1D and motion in 2D. Force, we are going to use some examples in which we will use force. Displacement, we will use it a lot today. Okay. So now we are going to study how vectors are added. Okay. Before that, we will also study some properties, but vectors are added using a different method. Okay. And the rules for adding vectors are different from that of scalars. So that we will study in some time. So before that, we will first study how to represent a vector. Okay. So we talked about the force being a vector quantity in the previous page. Now, how do we represent the vector? Okay. So you can draw the picture of a vector simply by using an arrow. Okay. Simply by using an arrow, or more specifically, an arrow with a direction. An arrow with a direction. Okay. Any vector that you want to represent, you can represent it as an arrow with a direction. Okay. Now the arrow has two parts to it: the length of the arrow and the direction in which it is pointing, right? So there are two parts to it. The length of the arrow, it tells us about the magnitude of a vector. Okay. So first let's give this arrow a name. So I'm going to give it the name A. And because this is a vector quantities, on top of the alphabet, we put an arrow like this. Okay. So whenever you see something like a vector, this means this is a vector quantity. Okay. This is the vector A. Okay. So whenever you have a symbol and on top of that an arrow like this, that represents a vector quantity. Okay. So this arrow, I gave it the name of A vector. So if this was a force vector, we will use the symbol F1 vector, F2 vector, and so on. Okay. Now there are two parts to a vector. So let's take the force example itself. First thing is the magnitude. Okay. Magnitude, and magnitude is basically how strong is the force. Okay. So is it a 50 Newton force, a 100 Newton force, a 30 Newton force? That is the magnitude part. Okay. This is the magnitude part of the force, which is how strong is the particular vector. Okay. So if it is a velocity, we will use 20 meters per second, for example. So that will be the magnitude. Then we will also have to specify the direction. Okay. And let's use east-west notation now. So I'm saying it is 50 newtons east. Okay. So when you say 50 newtons east, the thing that should pop up in your head is there is some block, let's say, and on this block of mass, there is a 50 Newton force that is being applied, and in which direction? In the east direction. So it will look something like this. Okay. So you draw this arrow. Okay. And this is the 50 Newton force. So this will be your F1 vector. Okay. So now if I have any random vector A, the length of the vector is an important information about the vector. The length indicates the magnitude. Okay. The length of the vector indicates the magnitude. So basically, the longer the vector, the greater the magnitude. So if you have to compare two vectors, let's say, I am telling you one vector is 50 Newton force. Okay. And it is in this direction. It's in the east direction. And then I give you another vector which is double the length of this one. Okay. If I tell you, so this is the original length, but double. Okay. So this yellow vector is 2x the length of the 50 Newton. Okay, I'm telling you guys that this pink vector is half the size of this yellow vector. So as I told you, the length of the vector tells us about the magnitude, right? So the longer the vector, the bigger the magnitude of the vector. So what was the magnitude of this vector? It was 50 Newton, right? So if this yellow is double the length, then the magnitude of this yellow vector will be 100 Newton. If it was triple the length, then it will be 50 into 3, which is 150 Newton. Okay, so bigger magnitudes, to indicate it as an arrow, you will have to use longer arrows. Okay, same with displacement also. If this is 1 meter displacement, for representing 2 meter displacement, you will have to use an arrow which is double the size. Okay, it's true for any vectors. So the length of an arrow indicates the magnitude, and the direction is given us by this arrow, right? The direction in which this arrow is pointing, that is the direction of the vector. Okay, direction of the vector. Okay, so this arrow direction is the direction of the vector. So if I draw a force vector like this, it means we are applying a 50 Newton in this direction. So you're pulling a block in this direction. If you're applying 50 Newton like this, it means you're pulling the block upwards. Okay, so you're pulling the block along this upward direction. So that is what the arrow direction is telling us. The arrow direction tells us about the direction of this vector. Okay, and the length of the arrow tells us the magnitude. So this is how we represent any vector. Whichever vector you want to represent, we will use an arrow to do it, and the direction of the arrow is the direction of the vector. Okay, so that is the first thing. How do we represent a vector? So now there are some simple types of vectors. Okay, these are just definitions itself. All right. So now, what are parallel vectors? Okay, parallel vectors. So parallel vectors have a very simple definition. If any two vectors are pointing in the same direction, okay, so I am drawing randomly two vectors. Let's give it a name of A vector and B vector. If they are pointing in the same direction, okay, like this vector is pointing along this line, this vector is also pointing along the same line. Okay, they're pointing in the same direction, then these vectors are called parallel vectors. Okay, A vector and B vector are parallel. Okay, A and B are parallel vectors. So parallel vectors have a simple definition. If they have the same direction, which means they are pointing along the same line. Okay, they're pointing along parallel lines basically, then they will be classified as parallel vectors. Okay, so 50 Newton force to the east and 30 Newton force to the east, these are both parallel, right? They are both in the same direction, east, so they will be parallel vectors. So if you move 10 meters to the north, okay, 10 meters to the north, this is going to be a 10 meter displacement, and if you move, let's say, 5 meters to the north, this is a 5 meter displacement, but both are north direction, right? Both are pointing along the north direction, so these two will also be parallel vectors. Essentially, if they are pointing in the same direction, we will call them as parallel vectors. Okay, now the next one is anti-parallel. So anti-parallel also has the similar definition itself. Anti-parallel means they are pointing in the opposite direction. So the first vector the first vector is let's say along this direction. The second vector will be pointing in the opposite direction, like this. Okay, so this will be, let's call it A vector. This, let's call it B vector. So it has nothing to do with the magnitude. Okay, it has only to do with the direction. So here A and B, A vector and B vector are anti-parallel. Okay, so if the vectors are pointing in the opposite direction, okay, like this vector is pointing along this line and this vector is pointing along this line, then they will be classified as anti-parallel. Okay, so the next one is equal vectors. Okay, this is an important one. This is an important one. When do we say two vectors are equal? Okay, this is very important. For two vectors to be equal, there is a fixed, there are two conditions. The first condition is their magnitudes must be equal. Magnitudes must be equal. Okay, so this means the length of the arrow should be the same. And secondly, they have to be parallel. They have to be parallel vectors. Second condition is they have to be parallel vectors. So what does this mean? Same direction, right? This means the same direction. So if we say two vectors are equal, then that means their magnitudes are the same, equal, and their direction is also the same. Okay, so let's take some vectors. So here I am choosing a vector like this. Okay, and I'm choosing another vector b like this. Okay, this is b vector. Okay, and if I ask you, is a vector and b vector equal? Then the answer is yes, they are equal. Yes, these two vectors are equal. You just have to look at two things. Are the length of the vectors equal? And are they pointing in the same direction? They are both pointing in the north. Okay, and their lengths are also equal. So these two vectors will be equal vectors. Okay. Now the magnitude of a vector, we use a certain symbol for that. Okay, there is a symbol to represent magnitude of a vector. Okay, so if our vector is A, then magnitude of A vector, it is represented in two ways. Either you can simply write A without the arrow. This also means magnitude of A vector. Or you can put the arrow, but put two vertical lines like this. Okay, so these are two ways to represent magnitude of a vector. So if I take an example, okay, and if I give you a force vector F1, and if I tell you it is 20 newtons in the east direction, then what is magnitude of F1? Which I can write it as F1. If I ask you magnitude of F1, I'm only asking you about this information. Okay, don't tell me about the direction. So magnitude of F1 will be simply 20 Newton. Okay. Similarly, if we have a displacement that is 50 meters along the northeast, and if I ask you magnitude of that displacement, so it will be only 50 meters. Okay. So if I ask you the magnitude, you only have to tell me the part excluding the direction. You don't have to tell me the directions information. Okay, I only want to know how strong the force is. So that is the magnitude, and these two letters are what we use to represent it. Okay, great. So I guess equal vectors are clear now. Okay, two vectors are only equal if they have same magnitude and the same direction. So a usual question which is confusing is, if I take a force of 50 Newton along the north, okay, and a force of 50 Newton along the east. Okay, if I take a force of 50 Newton along the east, okay, and I call this as F1 vector, and I call this as F2 vector. So tell me in the chat, guys, is f1 vector equal to f2 vector? Are they both equal? Okay, tell me, guys, are they equal? If two non-zero vectors are parallel, is their dot product always positive? Dot product sign only depends on the angle, okay, Kirtan? So if you have two vectors, let's say A vector and B vector, the sign of the dot product depends on this angle theta, right? So dot product's definition is AB cos theta, right? So A and B magnitude of vectors are always positive, okay? So this A is positive, B is also positive. Sign depends on this theta, cos theta. So, so when is cos theta negative? If you guys have studied some trigonometry, cos theta becomes negative when theta is obtuse. Theta is obtuse. Okay. So if theta is obtuse, which means theta is anywhere between 90 degree and 180 degree, that's when dot product becomes negative. Okay. So if this angle theta between the vectors, if this angle theta between the vectors is an obtuse angle, which means bigger than 90, then the dot product becomes negative. Okay. All right. So I guess nobody answered it. So F1 will not be equal to F2. Okay. So this is important. Why is the force not equal? Their magnitudes are equal, right? This force is also 50 Newton. This force is also 50 Newton. But their directions are different, right? F2 is along the east direction and F1 is along the north direction. Because the directions are not equal, the force vectors won't be equal. Okay. So the reason is directions are different. Directions are different. Their magnitudes are equal, right? So if I asked you the question, is magnitude of F1 equal to magnitude of F2, then this is correct. Okay, this is correct because they are both 50 Newton. 50 Newton equals 50 Newton, right? So magnitudes are definitely equal, but the vector is not equal. Okay. All right. Okay, so let's continue. Now, so now there is this thing called negative vector. So negative vector has a simple definition. Take any vector, A vector, okay? And if I ask you what is negative vector, that means minus of this vector A, minus of vector A. So if A vector is pointing in the east direction, minus A vector is the same vector, but it points in the west direction, okay? It's the same vector, but the direction is flipped. The direction is now flipped. It is towards the left. That's the only difference in minus A vector. So their magnitudes are the same. Okay, so both these vectors, for both these vectors, their magnitudes are the same. So their magnitudes are same, but the direction is opposite. Okay, so if A is pointing to the right, minus a will point to the left. Okay, so that is going to be the negative vector. So this is also something that is important to keep in mind. What does it mean by a negative vector? So if I ask you force F is 50 Newton east, okay, then what is minus F vector? For minus F vector, magnitude will be the same, so there is no difference there, but this will point in the west direction. Okay, this will point in the west direction. So F vector will be 50 Newton east and minus F vector will be 50 Newton west. This is F vector, this is minus F vector. Okay, so this is going to be negative of a vector. Then there is thing called collinear vectors. Collinear means along the same line. So let's draw some dotted lines like this. Okay, and if two vectors are collinear, that means they are pointing in the same direction along the same line. Okay, they're basically arranged in a train like this. So this is the first vector, this is the second vector, this is the third vector. Okay, something like this. So if they're arranged, if they're pointing in the same line like this, arranged in a train manner, then they are collinear. Okay, A, B, C, they are collinear vectors. Collinear vectors. Okay, so sometimes in different questions they will just mention this, A and B are collinear vectors. So this picture should come to your mind. Okay, vectors, you should always try to visualize it in terms of diagrams. Okay. All right. Next one. Next is the zero vector. Okay. So zero vector is a vector which has zero magnitude. Okay, it's as simple as that. It is a vector with zero magnitude. Okay, and its direction is not important. Its main idea is, if we have a zero vector, it's a vector with zero magnitude. Okay, we'll come across the usage of zero vector after some time. Okay, so now we will also discuss another important properties. Now, so I am drawing a random vector here and I'm giving it the name A vector. Okay, now there is an important idea here that you should all keep in mind. If I take a copy of this A vector, okay, like the perfect copy of this A vector, and if I move it around and place it somewhere else, okay, I am placing it in a different position. So I took it from this location and placed it over here. So in this process, from going from here to here, I didn't mess with the vector, right? The magnitude didn't change. Magnitude did not change. And the direction also did not change. Direction also did not change. So the only thing that changed is the position. Okay, so we just picked up this vector from here and placed it here. So if the magnitude of the vector did not change and the direction also did not change, then this is also a vector itself. Okay, there is no difference between this vector and this vector. So we discussed two vectors are equal if their magnitude is the same, if their length is the same, and they are pointing in the same direction. So you can pick up any vector and move it around. You just have to make sure that you don't change the magnitude or the direction. Okay, like if you like take it here, but instead you rotated it a little bit. Okay, now this is not a vector, this is a different vector. Okay, this vector is not a vector, this is some other vector, b vector, because the direction changed. The direction was changed. Okay, so when you take this vector and you rotate it a bit, now this vector is pointing in a different direction, which means the vector is now different. Okay, so this is an important property. You can pick up any vector and move it around, and if you don't change the magnitude and if you don't change the direction, the vector also does not change. Okay, so so this is an important property of vectors. Okay, now we will talk about addition of vectors. Okay, and we will use the displacement vector to understand this. We will use the displacement vector to understand this. Okay, now the definition of the displacement vector is pretty straightforward. Let's say we start from some point A. Okay, we start from some point A and we start moving towards another point B. Okay, after some time we came to this point B. The displacement of this person who started moving from A to B is simply a vector or an arrow which connects A to B. Okay, this is known as the displacement vector. Okay, so we use the symbol S for this. This is the displacement vector. It's simply a vector connecting or an arrow connecting the initial position to the final position. That is the displacement vector. Okay, now if I tell you that somebody started from location A, let's analyze something. So somebody started from position A and he walked north for 3 meters, let's say. Is this looking like north? Yeah, so it's looking like north. So he walked for 3 kilometers, let's say. And then he reached this point B. Okay, then he reached this point B. And then when he reached point P, he walked 4 kilometers to the east. Okay, he walked 4 kilometers to the east. And then he reached the final position of C. So in this process, what is the total displacement? What is the displacement vector? It is the vector connecting initial point to the final point, right? So the displacement vector, it will be this vector connecting A to C. This will be the total displacement. This will be the total displacement vector. So if I ask you what is the magnitude of displacement, what is the magnitude of displacement vector? How do we find it? Magnitude is simply the length of a vector, right? So magnitude of displacement vector means what is the length of this yellow arrow. So that you can use Pythagoras theorem. So this is just a right triangle. Okay, this is a simple right triangle. So this side length is 3, this side length is 4. So this, all of you know, it is going to be 5 kilometers, right? So what is magnitude of S? Magnitude of S vector will be 5 kilometers. Okay, so this example, I just wanted to explain how to write the displacement vector. Okay, so now we are going to use the displacement vector to understand vector addition. So let's take one vector which is a vector, okay, which is a displacement itself. This means the particle went from here, starting point A, to this point B, okay. Then from B, he displaced to another point C. From this point B, he displaced himself to another point C. That point C is over here. And this vector, this displacement vector, we can call it as B vector. What is the total displacement? So he in total went from A to C. So that is going to be an arrow connecting A to C. So we can either go from A to C directly, okay, along this yellow path, or we can go from A to B along this blue path, and then from B to C along this purple path. In both cases, the displacement finally is the same. Okay, so let's call this displacement as C vector. So if you go directly from A to C, then also displacement is C. Or if you go from A to B and then B to C, then also displacement is C. So which means if you add the two displacements, A vector and B vector, this means adding the two displacements, it will be equal to the final displacement. Okay, so this is the definition of vector addition. This vector A plus this vector B, the first displacement plus the second displacement will be equal to the total displacement, which is C. Okay, so this is known as triangle law of vector addition. Okay, this is known as triangle law of vector addition. Okay, and the reason is, if you add two vectors A and B, their sum, their vector sum. So what we are calculating here, this is the vector sum. Vector sum. We also call it as the resultant. Okay, we also call it as the resultant. If you are adding two vectors A and B, the sum is actually the third side of a triangle, right? So the two vectors and their sum form three sides of a triangle. So that's why this is called the triangle law of vector addition. So if I am taking another example, so this is, let's say, A vector, and this is, let's say, B vector. Okay, so this particle went from here to here and then from here to here. So what is the total displacement? So A vector plus B vector, the answer is going to be the third side of the triangle. The arrows are also important. Okay, the arrow order is also important. The two vectors being added, A vector and B vector. So if you notice, A vector's head is over here, right? Whenever we have a vector, the arrow tip is called the head of the vector, and the other end is known as the tail of the vector. Okay, so B is placed at the head of, B's tail is placed at the head of A vector. So the two vectors being added should be placed in this fashion. Okay, A vector like this, and on the head of A vector you will place the tail of B vector, and then the other side will be the resultant. Okay, the other side will be the resultant. Okay, so what if A vector was like this and B vector was like this? Okay, so this is where we started, this is where we ended. So this will be the resultant. Okay, so this is A vector, this is B vector, this will be the resultant, A vector plus B vector. Okay, so the resultants always form a triangle unless they are anti-parallel or parallel. So now let's take some cases. Okay, if A vector and B vector, if they are parallel, okay, if they are parallel. So then what I will do is I will place A vector like this. Parallel means they are in the same direction, right? So B vector, I will draw it something like this. I will put B vector's tail on A vector's head like this. So this is going to be B vector. So now what will be their vector sum? Always use displacement logic to understand the resultant or the sum. So we started from here and then we ended at this location. So what will be the resultant? The resultant will be this vector. The resultant will be this vector. Okay. So this will be your A vector plus B vector. Okay. And you can also call this side as the C vector. Okay. Now here I can also ask you, what is the magnitude of C? What is the magnitude of C? Or magnitude of A plus B? They mean the same thing. So once again, magnitude of C means length of this blue arrow, right? What is the length of this blue arrow? So because they are parallel to each other, right? There is a nice thing happening here. Because this blue arrow, this pink arrow and the white arrow are parallel to each other, you can say the length of this blue arrow is equal to length of this pink plus length of this white. So you can also write this as, what is the length of this pink vector? That will be mod A, right? Mod A, or you can simply write it as A. And what will be the length of this blue vector? That you can simply write it as B. So when two vectors are parallel to each other, their sum, their vector sum, you simply add their magnitude. So to take an example, if there is a 10 Newton force in this direction, right? Whatever applies to forces also applies to displacements, right? And a second force is also there, which is slightly longer, of 15 Newton. Okay, then what is the total force? What is the resultant force? The resultant force, because they are parallel vectors, the resultant force will be this vector firstly, and its magnitude will be, this side length is 10, this side length is 15, so 10 plus 15. So resultant force will have a magnitude of 10 plus 15, which is 25 Newton. So whenever the forces are, both the forces are applied along the same direction, the total sum, it simply adds up. Total resultant's magnitude will be simply their sum. Okay. So like the example can also be given like this. So we'll be given a block of mass and one force is applied at this point A of 10 Newton, and a second force is applied at this point. Second force is applied at this point of point B, and this is, let's say, 13 Newton. Because these two forces are parallel to each other, the total force, okay, which we can also call it as the net force, its magnitude will be 13 plus 10, which is 23 Newton. Okay. Zero vector be considered parallel to every vector. Zero vector's main purpose is its magnitude is 0. Okay, like its direction is not very important. So zero vector, we'll take a situation in which we get a zero vector. So this is the parallel addition case. Okay, when we have two vectors that are parallel, their magnitude simply add up. Okay. Now, if we have two vectors that are in the opposite direction, now let's come to two vectors that are facing the opposite direction. So this is your A vector. Okay. And let's use the displacement logic itself. We start from point A and we go to point B. This displacement, we call it as A vector. Then we start from point B, okay, after reaching point B, and we go to the left. So from point B, we go to some point C. That displacement, we will call it as B vector. Okay, so from this point B, we go to the left and we reach some other point C. This blue vector, we will call it as B vector. Now the question is, what is the total displacement in this case? So here A vector and B vector are opposite. Here A vector and B vector are opposite, right? So if they are opposite like this, then also the rule is same. We start from A and we end at C, right? So the resultant vector will be this one, starting from A, ending at C. This will be the sum. This will be the sum. So this is going to be A vector plus B vector. Okay. So this is the first displacement and then we return back. This is the second displacement. So if you add this displacement plus this displacement, you will get this displacement. Okay. So here if I ask you, if this third side length, if I also call it as C vector, if I ask you the length of C vector's magnitude, what will this be? So you can use distances once again. This distance is A, this distance is B, right? The blue length is B and the white length is A. So you will have to do A minus B to get the pink length. So the pink length, which is going to be the C, will be A minus B. A minus B. So which means if you have two vectors that are in the opposite direction, if we have two vectors that are in the opposite direction, then magnitude of their sum, it will be just their subtraction. You just have to subtract their magnitudes. Okay. So I'll take an example for this. So an example for this is, we can use the force example itself. So let's say one force is 20 Newton to the right, and we also apply a second force which is 10 Newton to the left. Okay, we apply a 20 Newton to the right and a 10 Newton to the left. So what is the total? Because the forces are opposite to each other, they will subtract, their magnitudes will subtract, and it will be, so 20 will win, right? 20 is the bigger force. So 20 to the right and 10 to the left means 20 will win. So this will be equal to 20 minus 10, which is 10 Newton. This is the net force or the resultant force. Okay, now this 10 Newton also, you can also place it here. Okay. So in the block, you can also do it this way. So you can apply one force here to the right and call it 50 Newton, let's say. And the second force, you can place it here to the left. And let's say this is 15 Newton. Here also the two forces are opposite to each other. Okay. And if the two forces are opposite to each other, then the total force will subtract. So 50 will win against 15. So 50 minus 15 will be 35, right? So it will be 35 Newton to the right. How did I get it? 50 minus 15 Newton. Okay. So if the forces are in the opposite direction, then the vectors subtract. Okay. So if I apply 50 to the right and 15 to the left, it is 50 minus 15, which is 35 to the right. What happens if both of them are equal? If the two forces are equal in magnitude, so this is, let's say, 20 Newton and this is also 20 Newton. So here, what is the sum of these two forces? If I call this F1 and this as F2, here because they are opposite, we will subtract them, but they are equal in magnitude. So what is 20 minus 20? It is 0. So here if you add these two vectors, you will get 0. Okay, you will get 0 as the answer. Okay, which means the block will not experience any net force. So in summary, if I have a block, if I have a block and if two forces are applied parallelly, then the net force is 10 plus 10. It gets added up, which is 20. And if the two forces are applied opposite to each other, then you will subtract them. So F net will be 10 minus 10, which is 0 Newton. Okay, 10 minus 10, which is 0 Newton. We will also, understand what happens when forces are at an angle to each other, right? Like if we apply one force in this direction and a second force in this direction, then what will be the net force? Okay, this we will understand. This we will discuss after some time. Okay, this we will discuss. Okay, great. So now what do we do? We can also discuss what happens when the vectors are perpendicular to each other. Okay, that is also easy to derive. So if one vector is along the x direction, so the vector I am considering as a displacement vector, let's say 30 meters, and a second vector is perpendicular to the first one, okay, and this is 40 meters. Then what is this vector plus this vector? Use triangle law, it is going to be this vector. And so this is the total displacement. And what will be the length of this displacement? Use Pythagoras. So if this is 30, this is 40, this will be 50 meters. Okay, this will be 50 meters. But if I give you a general triangle, if I take two general vectors, A vector and B vector, that are perpendicular to each other, okay, then the resultant is still the same. It's this hypotenuse. But what will be the magnitude? So if this is C vector, magnitude of C vector, which is the resultant, it will be root of A square plus B square, right? In the right angle triangle, this side length is root of base square plus perpendicular square, right? A square plus B square. That is what we did here also. Here also we did root of 30 square plus 40 square. That will give you 50. So in this case, when two vectors are perpendicular to each other, when two vectors A vector and B vector, any two vectors, when they are perpendicular to each other, then the resultant, its magnitude will be this, root of A square plus B square. So if we take another force example for that, if I apply two forces, one force in this direction and one force, let's say we apply it in this direction. This force, let's say it is 30 Newton along the right, and this force is 40 Newton along the north. Okay. Then what will be the total force? So if I'll call this as F1 vector, this as F2 vector, the total force, you will have to add these two forces. Okay. And we discussed that when the forces or two vectors are perpendicular to each other, the magnitude of the total force is root of 30 square plus 40 square, root of A square plus B square. So this will be 50 Newton. Okay, so the total force that is acting on this block is not 70, right? If you add 40 and 30, it will be 70, but it will be 50. It will be 50. 70 you will get when this 40 and 30 are parallel to each other. So if 40 is applied like this, then 40 plus 30 will be 70. Okay, so we discussed three cases. If they are parallel, you add the magnitudes 30 and 40, it will become 70. If they are opposite to each other, then you subtract them, 40 minus 30. And if they are perpendicular, you use the Pythagoras relation to get the magnitude. Okay. All right. So now we will see how to get the magnitude if the two vectors are making an angle. Okay. So we discussed three cases, but there are more cases, right? So this is the first vector and this is the second vector. So what is the resultant? Resultant is going to be this vector. Okay. So this is your A vector, this is your B vector, this is your A plus B vector. Okay, which we can also call C vector. So we need to find the length of this side of the triangle. Okay, which is magnitude of C. Which is magnitude of C. This is what we want. Okay, so we will use some trigonometry here. First thing is, let's just take just a second. So let me extend this line. And I'm taking this angle as theta. This angle as theta. So what is this angle theta? That is very important. Okay. Angle between vectors. Angle between two vectors. Okay. So when you're given two vectors, and the information is given that the angle between the two vectors is theta. Which angle are they talking about? Right? There can be two possibilities for angle. Right? If let's say this is vector 1, this is vector 2, there can be two angles here that we can choose as angle between vectors, right? One is this one, let's call it theta 1. The second angle is this one, let's call it theta 2. So the question arises, which angle do we choose as the angle between the two vectors? And the answer is we will choose theta 2. Okay, here theta 2 is the angle between the two vectors. So angle between the two vectors, the easiest way to understand it is, this purple vector, it is pointing in this direction, right? It is pointing in this direction. So you extend this line, it is pointing in this direction. and this second vector is pointing in this direction. So direction of first vector is in this direction, direction of the second vector is in this direction. The angle between them, the angle between the two directions is what we take as the angle between the vectors. Okay. So I'll take an example for that. So this is, let's say, vector number 1. This is, let's say, vector number 2. And I want to find the angle between them. Okay. Let's say this angle is given to be 110 degrees. So if I ask you what is the angle between the two vectors, first what you have to do is, okay, this vector is pointing in this direction. So you can extend that line. Okay. Extend that line. So the angle between this direction and this direction, this is the angle between the vectors. Okay. So this will be what? Use angle sum. So total is 180. So this should be 70 degree. Okay. So the answer here is 70 degree and not 110 degree. Okay. Now, if the vectors are given to you in this fashion, okay, if they are attached tail to tail, they are attached in the tail to tail orientation, and this angle is given to be 30 degrees. Okay. So if this is vector A and this is vector B, in this case, angle between A and B is 30 itself. Angle between A vector and B vector, it is 30 degree itself. Okay. Because here direction of A is to the right, direction of B is in this direction. The angle between their directions is 30 degrees. But here direction of this vector is in this direction, direction of this vector is in this direction. So you have to choose this angle, which is 70 degree. Okay. So angle between two vectors is the angle between their directions. So this is the angle between the vector A and vector B. Okay. So whenever you're given a question and they are mentioning angle between two vectors is, let's say, 30, they're talking about this angle. Okay. So now the goal is we need to find the length of this purple side. Okay. So let's do that. So we'll use some trigonometry, some constructions here. So drop a perpendicular onto this side like this. Okay. Now the length of this white side is B, right? Simply B. So using trigonometry, I can find out this side length and this side length. Okay, that is pretty easy. In this triangle, write down cos theta. So say this is equal to x and this is equal to y. So if you write cos theta in this triangle, it will be x divided by b. So from here you can get x as b cos theta. Okay. So this base is nothing but b into cos theta. Now if you write sin theta in this triangle, that will be y divided by b. So from here y is equal to b sin theta. So the height is actually b sin theta and the base is b cos theta. Okay. Now we can use Pythagoras in this full triangle. So if I say this is A, B, C, I can use Pythagoras in this big triangle ABC. Okay. So if I do that, hypotenuse is the resultant itself. So that will be C square. So hypotenuse square is equal to base square. Base is, this length is A, this length is B cos theta. So base is A plus B cos theta whole square plus height square. Height square will be B square sin square theta. Right? Height of this triangle is B sin theta. So now you open this up. So if you open it up, it will be A square plus B square cos square plus B square sin square will become B square. And then we have 2AB cos theta. Okay, 2AB cos theta. So the magnitude of the resultant, okay, this formula is essential. So this C will be root of A square plus B square plus 2AB cos theta. This is the resultant C. Okay. So if we are adding two vectors A and B, okay, the length or the magnitude of the resultant is given to us by this formula. Okay. All right. Okay. So the thing is, you can also apply the previously discussed results. Like if you put theta equal to 0 degree, that means they are parallel vectors, right? A vector and B vector are parallel. So for theta equal to 0 degree, we would expect this would become A plus B, right? So C is going to be root of A square plus B square plus 2AB, which is A plus B the whole square. So what is root of A plus B the whole square? It will become A plus B, right? So this is what we expected. And when they are opposite to each other, then theta will be 180 degree. So in this case, we will expect A minus B, right? Or B minus A. So here we will have root of A square plus B square plus 2AB into cos 180. Cos 180 is minus 1. So it will become A square plus B square minus 2AB, which is A minus B the whole square. Okay, so now this you cannot write it as A minus B, okay, because B can also be bigger than A. So if B is bigger than A, this will become negative, right? If B is bigger than A, this is going to be negative, and square root of something cannot be negative. So we put a mod sign here, okay, mod sign here, which means even if this is negative, even if the inside thing is coming out as negative, we just take the positive value, okay. So this is also what we expected, okay. Then for theta equal to 90 degree, it should be root of A square plus B square, right? So for theta equal to 90 degree, it should be root of A square plus B square, okay. And because cos theta will become 0. If you put theta is 90, this will become 0, and you will get the answer as root of A square plus B square. Okay, this also we discussed, okay. So if they give the angle as, let's say, 60 degree, then you will have to put theta equal to 60 in this formula. Then you will get the total resultant, okay. So this is how we add vectors. So now we can talk about unit vectors, okay. Okay, now we'll discuss unit vectors. Now, so what is a unit vector? So unit vector, so let's say we take a random vector whose magnitude is A, and we'll call this vector as A vector. Okay, so A vector has magnitude of A, right? Its magnitude is A, and it is pointing in this direction. Now unit vector, as the name has it, in the name we have unit, that means 1, right? So unit vector is a vector whose main purpose is to tell us the direction. So this pink vector has the length A, okay, its length is equal to A because A is the magnitude. If I want a vector whose length is 1 unit, whose length is 1, which means its magnitude is 1, and it is pointing in this direction, we will say this vector is the unit vector along A vector's direction. Okay, so here we have an A vector, and if I choose a vector whose magnitude is 1 in the direction of A vector, I will say this is the unit vector along A direction. Okay, and there is a symbol we use to represent this. The symbol is A, and on top of A we put a cap like this. Okay, so whenever you see A cap, that means it's a vector whose length is 1 and it's in the direction of A vector. Okay, so this is how we represent unit vectors. Okay, so that's the unit vector. Now if let's say we have vector A, this vector A, as I said, the length of the vector A or its magnitude is A, right? Simply A. So I can write the vector A as its magnitude multiplied by the direction, right? Any vector I can write it as its magnitude multiplied by its direction. So the magnitude of A is simply A itself, right? And to provide the direction, we get the help of the unit vector. Okay, so A into A cap. So any vector I can write it as its magnitude multiplied by its unit vector. Okay, so if you multiply the magnitude of any vector to the unit vector, I will get the full vector. Okay, so this is also the method to calculate the unit vector. So from here, if you rearrange to find A cap, it will be A vector divided by magnitude of A, like this. Okay, so if you take this A to the denominator, if you divide the vector with its magnitude, you will get the unit vector. Okay, so we'll explore the unit vector a little bit more. A into A cap, yes. Okay, so now we will learn about 3 unit vectors. Now we will bring the XYZ coordinate system also. So if this is the x-axis and if this is the y-axis and if this is the z-axis, okay, and I want to so the thing is, if there is a unit vector, the unit vector along the x direction, okay, a vector whose length is 1, a vector whose length is 1 and it is along the x direction, this has, we give it the name of I cap. Okay, a vector whose length is 1 and it is along the x direction, we give it the name of I cap. Okay, it's given the name of I cap. So whenever you say I cap, that means unit vector along the x direction. And whenever you see the unit vector along y direction, that is represented using the symbol J. So this is represented as J cap, and the unit vector along the z direction, it is represented as K cap. Okay, IJK. I is any unit vector along x direction, J is any unit vector along y direction, and K is any unit vector along the z direction. So if I want to, so let's say this is the x-axis. Okay, this is the origin, and I want to plot a vector. I want to graph a vector whose magnitude is 3 units, okay, its magnitude is 3 units, and direction is in the x-axis. Direction is in the x-axis, so it's pointing along the x direction. Okay, then how do I graph it? How do I draw it? So if I call this vector as a vector, I can write any vector as its magnitude times the unit vector, right? Magnitude is 3 units times the unit vector, and the unit vector along x direction is I cap. So whenever you see 3 I cap, that means the length of the vector is 3 and the direction is in the x direction. So we will draw a vector whose length is 3 units in the x direction. Okay, so this is going to be, I'm assuming, the x direction. So we will draw an arrow whose length is 3, whose magnitude is 3 units, and it is along the x direction. So this is your 3 I cap vector. So I hope the meaning of 3 I cap is understood. So similarly, what does 4 j cap mean? So if this is the y-axis, this is the y-axis, 4 j cap is any vector which has the magnitude of 4 and it's in the j cap direction. J cap means along the y direction. Okay, so any vector whose magnitude is 4 and it is pointing along the y direction is 4 j cap, and k cap also, I hope it is clear. If I say another vector as 5 k cap, you will draw an arrow whose length is 5 units along the k direction, along the k cap direction. Okay, now we will combine these two. Okay, so this is let's say the x, this is the y direction, and there is a vector I am giving, calling it as a vector, which is 3 I cap plus 4 j cap. Okay, so how do I understand this thing? So here what we are doing is, when you're given any vector like this, 3 I cap plus 4 j cap, this means you can consider 3 I cap as the first vector and 4 j cap as the second vector. Okay, and then you know how to add two vectors, right? You can use triangle law. So the first vector is 3 I cap, which is a vector whose length is 3 and along the x direction. So that 3 I cap will look something like this. Okay, the 3 I cap will look something like this, and then to this 3 I cap I have to add the second vector 4 j cap. So that will look like this. J cap means it is along the y direction, parallel to y direction. So this side has a length of 4, this side has a length of 3. So okay, so what is the total vector? The resultant vector will be, using triangle law, it is going to be this vector. Okay, it is going to be this vector. So this purple vector is your a vector. Okay, so whenever you are given a vector like this, 3 I cap plus 4 j cap, how do you find the total vector? You add them one by one. So 3 I cap is a vector whose length is 3 and it is along the x direction. 4 j cap is a vector whose length is 4 along the y direction. Now you place them head to tail and you add them using triangle law. The resultant that you get will be your A vector. Okay. So whenever you see a vector like this, 3 I cap plus 4 j cap, this image should come in your mind. Okay. So the x direction we have 3, y direction we have 4. All right. So now what do we cover? So now the thing is, we will learn about resolving a vector. All right. So draw the x and y axis. Okay. So now here I am taking a vector which looks like this. Okay. And I'm giving it the name of A vector. I'm giving it the name of A vector. Now, what does resolving a vector along x and y direction mean? That is kind of the opposite process of what we did here. Okay. So here we wanted to find A vector, but we knew its I direction component and J direction component, right? So we wanted to find out. So actually I'll explain it here itself. So x component of any vector. So what do we mean by resolving a vector along x and y direction? So first thing is you have to drop a perpendicular onto the x-axis. Okay. Something like this. You have to drop a perpendicular onto the x-axis. And this A vector, I can also write it as, I can write it in a different way. Okay. I can write A vector as this vector over here plus this vector, right? This vector plus this vector, I can write it as the A vector. So what I'm doing here is, if I know this angle theta, and let's say this side length, I'm giving it the name AX. Okay. This side length, I'm giving it a name AX. And this side length, I'm giving it a name AY. So I can write A vector as AX and AY, their sum, right? So A vector, I can also write it as, so this length is AX. And what is the direction of this yellow vector? It is along the x direction. So unit vector will be I cap, right? And for this blue vector, the length is AY and the direction is in the j cap direction. Okay, the direction is in the j cap direction. So this A vector, I can write it as AX I cap plus AY j cap. This AX is known as the x component. X component. And this AY is known as the y component. Okay. You can also write it in terms of theta. So if you use cos theta in this triangle, it will be AX divided by A. And sine theta in this triangle, it will be AY divided by A. So what is AX? AX is A cos theta. And what is AY? AY is A sine theta. This you should also remember, okay? If you have a right triangle, okay, and one side is A and this angle is theta, so the hypotenuse length is A. So the side adjacent to this angle theta, it is A cos theta, okay, and the side opposite to this angle theta is A sine theta. Okay, so I can also write the same thing as a cos theta I cap plus a sin theta j cap. This way also I can write a vector. So whenever a vector is given as some I cap plus j cap, I hope it will be clear from now what does that mean. Okay, like here the vector was expressed as 3 I cap plus 4 j cap. Okay, this meant the x component is 3 and the y component is 4. So now we will do two questions. Okay, so first question is xy plane is given and you have to plot two vectors. Okay, so the first vector is 7 I cap plus 3 j cap, and the second vector is 4 I cap minus 3 j cap minus 3 j cap. Okay, we'll also cover what does it mean by minus j. So the first vector is easy. The x component is 7. So we will draw a 7 unit length arrow along the x axis and a 3 unit length along the y direction, something like this. So this is 7 I cap. This is 3 j cap. So the resultant will be this one. Okay, and this will be your 7 I cap plus 3 j cap. So 7i plus 3j means 7 along the x, 3 along the y. So x component is 7, y component is 3. Now 4 I cap minus 3 j cap. Okay, so let's also plot that. So that I'll plot it in another diagram here. I'll plot it here. So 4 I cap means 4 along the plus I direction, which is the plus x direction. But here instead of plus 3j, we have a minus 3j. Now plus 3j means it is 3 upwards. Negative of a vector is in the opposite direction, right? So we will go 3 below. So if you see minus 3j, that means go 3 below, okay? Opposite to j, opposite to the y direction. So this is going to be 4i. This is going to be the minus 3j vector. And if you add these two, this is going to be the resultant by triangle law, right? So this is going to be your 4i cap minus 3j cap. So here the x component is 4, y component is minus 3. Okay, y component will be minus 3. So if any vector is given in I and j, this is how you are going to plot it. Okay, the number that comes before I is the x component and the number that comes before j is the y component. Now we will do the opposite exercise. The axis, let's say, is given, and now the total vector is given, and the vector, let's say, has a magnitude of 5 units, and this angle is 30 degrees. Okay, instead of 5 I am taking 10 units. Okay, and the angle is 30. You have to express this vector. Okay, call this vector as a vector. You have to express this vector as I cap and j cap in the component form. So how do we do it? Find the x and y component. Okay, so we'll drop a perpendicular. This length will be the x component. This length will be the y component, right? So what is this component? 10 cos 30. Using trigonometry, this side length is 10 cos 30, which is 10 root 3 by 2 or 5 root 3, right? And this side length is 10 sin 30, which is 10 by 2 or 5. So now I can express a vector in I and j cap. So in I and j cap, it will be 5 root 3 along the I direction, 5 root 3 along the I direction, and 5 along the J direction, 5 along the J direction. So this is A vector expressed as I cap and J cap components. Okay. Yeah, so do you guys want a break? 5-minute break? Okay, so then, yeah, so then let's take a break for 5 minutes. Okay. I'll put a timer here. All right, so take a break, guys. Okay. Okay, so yeah, let's begin. Okay, so we have discussed the component form, right? How to break any vector into its I and j components. And we also understood what does it mean when we see a vector written like this, 3i cap plus 4j cap. Okay, so these two things should be clear, guys. Whenever you see any vector which is written like 3i plus 4j, it is a vector which has 3 along the x and 4 along the j in terms of length. Okay, so that's the first thing. Now the thing is, there is this parallelogram law of vector addition. This is not that different from what we did. So far we learned if we have two vectors a and b, and if we attach them head to tail like this, such that this is your a vector, this is your b vector. Okay, if you attach them head to tail like this, then this is the resultant, right? The third side of the triangle. This is your a vector plus b vector, right? This we studied. Now, parallelogram law is useful when you are placing the vectors tail to tail, right? Tail of b vector is over here at O, and tail of a vector is also at O. So if you place them tail to tail like this, then what you need to do is complete a parallelogram. Okay, so take this a vector and place it here, take this b vector and place it here, and complete the parallelogram. The diagonal of the parallelogram gives us the resultant vector. Okay, or basically in this diagram that we are seeing, so in this particular diagram, if I grab this b vector, okay, so I can take this b vector and place it everywhere, anywhere I want. So I am going to place it here. Okay, I'm going to place it here. Okay, and so I'm going to erase the a plus b for now, and then I'm going to grab the a vector, and if I place it here, then I complete the parallelogram. Okay, and now as you can see, if this is b vector, this will also be b vector, and if this is a vector, this will also be a vector. Okay, so here it's simply the triangle law of vector addition itself. This is the diagonal of the parallelogram, and this is going to be your a vector plus b vector. Okay, so there are two ways to see it. Either you can use triangle law, which is like you have to put a vector's head at b vector's tail, then this will be the diagonal, this will be the resultant, a vector plus b vector. Or if you are placing them tail to tail, like if you place a vector's tail and b vector's tail at the same point, then the diagonal will be something like this. Okay, such that it is the diagonal of this parallelogram. So it's just another way of looking at vector addition. There's no difference from the triangle law. Okay, and if this angle is theta, if the angle between a and b is theta, we already learned how to find the magnitude, right? So magnitude's formula was root of a square plus b square plus 2ab cos theta. So there is no difference here also. Okay, with an under root. So parallelogram law is not that different. Okay, it's the same itself. It's just that we are picking one vector and placing it here, finishing a parallelogram, and we also notice that the resultant is also the diagonal of the parallelogram. Okay, so that is it. Now we can do some questions. Okay, so you guys can try this out. So the first question is, we have two forces, magnitude of 3 Newton and 4 Newton. They are acting on a body. What is the resultant force if the angle between them is 0 degree? So in the first part, situation is like this: block of mass, and 3 Newton and 4 Newton are applied parallel to each other. Okay, then what is the resultant? So that is the first question. Okay, so in this case it is easy. What is the angle between the two vectors? It is 0 degree, right? The angle between first vector and second vector are 0. And this you should anyway remember. If we have two vectors that are parallel to each other, always the resultant vector is simply the sum. Okay, resultant vector will be 3 plus 4, which is 7 Newton in the same direction. Okay, so this will be 7 Newton. Now in the 180-degree case, second one is a 180-degree case. 180-degree case means they are opposite. Okay, so 4 is applied like this, 4 Newton is applied like this, and 3 Newton is applied in the opposite direction. So in this case, what will be the force? In this case, what will be the force? Here it's going to be A minus B, right? So using common sense, we can see that 4 Newton is bigger than 3 Newton. So in a tug of war, 4 Newton will win, right? So the resultant force will be to the right, and it will be 4 minus 3, which is 1 Newton. Okay. Now in the third case, we have the 90-degree example. So in the third example, we have 4 Newton and 3 Newton applied at a 90-degree angle. Okay, so here the net force will be at some angle, right? If we go by parallelogram law, it will be in this direction, right? Complete this parallelogram, which is a rectangle. So this will be the resultant, right? So the net force will be in this direction, something like this. And what will be the magnitude? 4 square plus 3 square under root, which is 5, right? So this is going to be 5 Newton. Can I also find this angle? So if I call this angle as alpha, so in this triangle, so this is 4 Newton, this was 3 Newton, right? This was 3 Newton. So complete the parallelogram here. So if you do that, take this and place it here, take this and place it here. So what is the resultant? Resultant is the diagonal of this parallelogram. In this case, it is a rectangle, right? So this is 3, this is 4. So this is also 4 and this is 3, right? So if I want this angle, which I called it as alpha, how will I find it? I can find tan alpha, right? So tan alpha is coming out to be 3 by 4 here. Okay. Now tan alpha is 3 by 4 for 37 degrees, right? So if you guys remember the value, tan theta is 3 by 4 for 37 degrees. So here this alpha will be 37 degrees. Okay. Here this alpha will be 37 degrees. Now if in another example, let's say tan alpha came out as 1 by root 3, then you will say alpha is 30 degrees, for example. Okay, so that's how we find the resultant in these three cases. Yes, 7, 1 and 5. That is correct. Yes, yeah, that is correct. Okay, so next question is this one. So here we have two vectors of equal magnitude of 5 units, and they have an angle of 60 degrees between them. So you have to find the magnitude of their resultant vector and its angle from one of the vectors. Okay, so I'll draw the diagram. So the diagram is, we have two equal vectors, 5 units each. Okay, now what is the angle between the vectors? It's 60 degree. So I'm drawing them tail to tail like this, so that I can directly draw the angle between the vectors as 60 degree. So if you attach them tail to tail, the angle between them is the angle between the vectors itself, the 60-degree angle. Then they're asking what is the magnitude of the resultant vector and angle from one of the vectors. Okay, so these two are 5 units, 5 each. Okay, so complete the parallelogram here, right? Complete the parallelogram here. So resultant is the diagonal of the parallelogram, right? This diagonal. So we already found out the magnitude earlier. We already found out the magnitude earlier. So for magnitude, you can simply use the direct formula, right? So if I say this magnitude is C square, you can write it as A square plus B square plus 2AB cos 60. So you can write it as 5 square plus 5 square plus 2 into A into B into cos 60, which is half, right? So cos 60 cancels out with 2. What is 5 square plus 5 square plus 5 square? It is 75, right? Or in other words, C you can write it as, if you take the 5 outside, you can write it as 5 root 3 units. So this is the resultant's magnitude. It is 5 root 3. It is 5 root 3. Now what you can do is, if I know this side length is 5, in this right triangle, what is this side length? 5 cos 60, right? 5 cos 60. So I'm directly writing it as 5 by 2. And what is this side length? 5 sin 60, which is 5 root 3 by 2. Okay, 5 root 3 by 2. Now, in the question, they're asking what is the angle from one of the vectors? From one of the vectors. So, this is the resultant. I want the angle of this resultant from one of the vectors. So, I'm calling this as alpha. Now, mark this triangle ABC. Okay, so that is a right angle triangle. So, that you try to draw it here. So, this is the alpha angle. What is the side length BC? It is 5 root 3 by 2. And what is the side length AC? It is 5 plus 5 by 2, which is 15 by 2. Right? It is 15 by 2. So try to find tan alpha. Try to find tan alpha. It will be opposite upon adjacent. So 5 root 3 by 2 divided by 15 by 2. So 2 goes away. This cancels out as 3. Root 3 by 3 is 1 by root 3. Okay. Tan alpha is 1 by root 3 implies alpha is 30 degrees. So we got the angle as well. So you can also remember this as a result. If you have two vectors, who have equal magnitude means they have the same length. Okay. So they have the same length. So this has a length, this also has a length. Then the resultant will be along the angle bisector. Okay. Then the resultant will be along the angle bisector. Angle bisector is a line that cuts the angle in half. Okay. So resultant will be along angle bisector. Okay, so that means if the whole angle is theta, it will cut the angle into two halves. Okay, so you can say the resultant makes an angle theta by 2 with either of the vectors. So here also we have a similar situation. We have two vectors of equal magnitude, which means their resultant will be along the angle bisector. So what is the half of 60? It is 30. Okay, so this angle will be 30 degrees. So yeah, magnitude 5 root 3, angle is 30 degree. Yes, that is correct. Great. Okay, so that I hope is clear. Now there is also a direct formula for this angle alpha. Like, I mean, you can remember it like that also in our derivation page. In this particular page, if you remember, from here also you can get a formula for tan alpha, right? For tan alpha, it is going to be this height, which is b sine theta, divided by total base length, which is a plus b cos theta. Okay. So you can get a formula as well for this, or you can draw the triangle manually. Okay. So that is how we calculate the angle. This is the next one. Okay. This is the next one. Okay. You guys can try to do this. Try to solve this. Try to solve this. Take like 1 minute 30 seconds. So here they're saying two vectors have equal magnitude, have a resultant equal to either of them in magnitude. Okay, they have given a statement and they're asking what is the angle between them. Okay, so in vectors question, it is actually useful if you draw a diagram. Okay, if you try to draw the vectors on a diagram, it's actually helpful. 120. Okay, so let's see, wait a second. So here the hint given is two vectors of equal magnitude have a resultant equal to either of them in magnitude. Okay, so if you can draw the diagram here, then you can directly get the answer. Okay, so let's say this is the first vector. Okay, and I'm going to call this side length as a. So they're saying the two vectors that are being added have equal magnitude. Okay, so the second vector, I don't know how it looks, but it must have the same magnitude a, right? I don't know the angle between them, but I can say their magnitude is the same. So this arrow's length and this arrow's length must be equal. Now, the third thing is what makes this question interesting. So they're saying the resultant also has the same magnitude. Okay, which means this is not the diagram. It will be an equilateral triangle. Okay, it will be an equilateral triangle because all the three side lengths are equal, right? All the three side lengths are equal. So the first vector, the second vector side is also a, the third vector side is also a. So they must form an equilateral triangle. Okay, so because the two vectors and the resultant have the same magnitude, these three vectors will form an equilateral triangle. Okay, now the thing is you have to be a bit careful. What is the angle between vectors? So this is the direction of the first vector, okay? And this is the second vector. This is the angle between the vectors, okay? This angle theta we have to calculate. Now for an equilateral triangle, all the three angles are 60. So this angle is 60 degree. So what will this angle be? It will be 120 degrees. It will be 120 degrees. So you guys were correct? Yes, it is 120. Okay, so what is a manual way to do it? For manual way, you can use this formula, this tan alpha formula, whatever that was. Yeah, so tan alpha was b sine theta divided by a plus b cos theta. Okay, so you can write tan alpha as b sine theta. B and a, they are both same. So I'm using a itself, sine theta. Okay, wait a second. You actually can't use this. You will have to use the magnitude formula, right? So a square will be equal to a square plus 2 into a into cos theta. You can use this formula, right? Resultant's magnitude and two vectors also have the same magnitude. Sorry, there won't be a square here, square root here. So one a square goes away. So if you take it to the other side, you will get cos theta equal to minus half. So this means theta will be 120 degree. Cos theta equal to minus half happens at theta equal to 120 degree. Or you can use this trick, okay, that vectors will form a equilateral triangle. The three vectors form an equilateral triangle, okay. Great. The next one is this thing. So here we have two vectors whose magnitudes are 6 and 8 units, okay, and they're perpendicular to each other. Then what is the magnitude of the resultant, okay? So we have two vectors, 6 units and 8 units. 6 Newton, not 6 Newton, 6 and 8. And they are perpendicular to each other. So what is the magnitude of their resultant, okay? So what will be the magnitude of their resultant? So here, what will be the answer, guys? Tell me. Here, what will be the answer? So here we have two vectors that are perpendicular, right? So the magnitude will be root of 6 square plus 8 square, right? So what is this thing? This is 36 and 64. What is their sum? 100. Square root of 100 is 10. Okay, so the answer will be 10 here. All right. 10. Yes, Johnny, that's correct. Next thing is we have two vectors each of magnitude 10 units act at a 120 degree angle. So here what will be the resultant? Here what will be the resultant? So these are just direct formula based ones, okay? This is directly formula based. So here if they are both 10 units each, then this will be 10 square plus 10 square plus 2 into 10 into 10, that will be 10 square. Cos 120 will be minus half. Okay, it will be minus half. So this 10 square goes away and only thing that is left is 10. Okay, so the answer will be 10 itself. Okay, here the answer will be 10. Yes, it will be 10 again. Now, so now tell me the answer for this. So here they're asking, there are two vectors. Okay, first vector has 12 magnitude and the second one has 5. So there are two arrows basically. One has 12 unit magnitude and one has 5 unit magnitude. The question is, what is the max possible magnitude of the resultant? Okay, so basically if you take this 5 unit and you can place it here and you try to add these two vectors, the resultant's magnitude will depend on this angle theta. What is the maximum possible value of the resultant? So that is the question. Yes, it is going to be 17. Yes, why is it 17? Because maximum resultant happens when they are parallel, right? So maximum value of the resultant happens when the two vectors are parallel to each other. In this case, we simply add them up. Okay. In this case, the resultant, we simply add them up and we get a 17 unit vector. Okay. So the answer will be 17 here. And the minimum case also, now I guess it is straightforward. For minimum case, what will you do? You will put them opposite to each other, right? So you will put the 12 like this and the 5 like this. Okay, this will give you the minimum possible resultant, which is a 7. 12 minus 5, which is a 7. Yes, okay. So you can also say that for minimum, if we have two vectors, A vector and B vector, okay, you can also generalize it this way. A vector plus B vector, its maximum value is going to be A plus B. Okay, and its minimum value will be that A minus B, subtraction. Okay. This is the maximum value of the resultant, max value of resultant, and this is the minimum value. This is going to be the minimum value. Okay. So basically A plus B's magnitude, it cannot be less than this value or it cannot be bigger than this value. Great. So now we will talk about what does it mean to subtract two vectors, okay? So subtraction of vectors is not very different because we will use addition itself to understand this. So if we have one vector A vector and another vector that is, let's say, B vector, which looks like this, B vector looks like this, then what was A vector plus B vector? That was this vector over here, right? This was their vector sum. This was A vector plus B vector. Now we will plot what is A vector minus B vector. Okay. So for this, we will use an idea here. If we have A vector plus minus B vector, so here we are trying to subtract B vector from A vector. This we are going to slightly modify and write it as A vector plus negative of B vector. Okay. This is because we know how to add two vectors. Okay. And we also know how to find minus B vector. what was negative of a vector? Vector opposite to B vector with same magnitude, right? That was minus B vector. So we will write A minus B as the sum of A vector and minus B vector. So there is nothing new here. What we'll do is we'll take B vector and flip it basically. Okay. So if I take B vector outside, this is your B vector. So minus B vector will be rotated 180 degree. This is going to be your minus B vector. Okay. So we took B vector and rotated it 180 degree, which means opposite direction. The vector that we get is the minus B vector. This is the minus B vector. So now if we add A vector and minus B vector by triangle law, this is going to be the resultant. Okay. This is going to be your A vector plus minus B vector, which is simply A minus B. So all we have to do is find out the angle between the vectors now. We already have the formula. So if I extend this line, let's say the angle between A vector and B vector, it was theta, same as before. Okay. So what is the angle between A vector and minus B vector? That is going to be this angle, right? This angle is 180 minus theta. So all we have to do is, if I want the magnitude of this vector, if I want the magnitude of A minus B, all I have to do is, to the original formula, which is A square plus B square plus 2AB cos, instead of the angle between A and B, we will now put the angle between A and minus B, right? The angle between A and minus B is 180 minus theta. So we will put an angle of 180 minus theta here. So this will be square root of A square plus B square. Now this is a trigonometric identity. So cos 180 minus theta is actually minus cos theta. So there will be a minus 2AB cos theta. Okay. So from the mod of A plus B formula, the only difference is, instead of a plus here, we will have a minus. No, Johnny, the magnitude will be different, right? As you can see, this magnitude is different compared to the A plus B formula, right? The A plus B formula was A square plus B square plus 2AB cos theta with an under root, and here you have a negative, right? So magnitudes are not different, and from this diagram also you can see A plus B's length is different from A minus B's length, right? So they're not the same. Okay, they're not the same. Direction and magnitude would be different, and they can be equal in one case. For example, if you put theta equal to 90, then both of them will be equal, right? But in general, they are different. So this blue length and yellow length are different. Okay. All right. So now we have this question: magnitude of the difference of two equal vectors making an angle of 60 degree. So difference of two vectors means they're asking subtraction, right? A vector minus B vector is what they're asking, and its magnitude is what they're asking. So this will be root of, they are equal vectors. Okay, and I guess their magnitude, they are taking it as A. So this will be A square plus A square minus 2 into A, which is A square, into cos of angle between A and B, which is cos 60. So this will be what? A itself, right? This is going to be A itself. By mind can't process it because magnitude of A and B is the same. Magnitude of A and B will be different, right? Magnitude of A is this, magnitude of B is this. So they don't have to be the same, right? All right, so I hope this question is clear. So in the A minus B formula, there is just a minus here. That's the only difference. So now the magnitudes of A plus B equals the magnitude of A minus B. Then they're asking the angle between A and B. Okay, this we just discussed. When is A plus B and A minus B equal? When are these two formulas equal? It's when theta is 90, right? If you put theta equal to 90, this term becomes 0 and this term also becomes 0. So in that case, this is root A square plus B square. This is also root A square plus B square. So it becomes 0 when theta is 90 degree, right? So that is going to be the answer here. They are going to be equal when theta is 90 degree. Okay. Now, a vector of 20 units make an angle of 60 degree with the positive x-axis. Its x component is. Okay, so they're asking about the x component now. So 20 unit vector. Try this out, guys. Tell me the answer. So what was the x component? So if I drop a perpendicular onto the x-axis like this was the x component of a vector A, right? If I had a vector A, this was the x component of that vector A, right? So what is the x component here, guys? Tell me. What will be the x component here? C. It's going to be a B, right? So so basically the magnitude of A is given to be 20 units, right? And it's making 60 degrees with the x-axis. This side is the x component, right? This is 20 cos 60. This is 20 cos 60 and this side is actually 20 sin 60. Okay, so 20 into half is 10. So 10 is the x component and 10 root 3 is the y component. Okay, so it will be the y component, that is 10 root 3. The x component will be 10. Okay, great. Now what about this one? Here we have been given a vector. Okay, a vector is given. I and j are also given components. And they're saying it's a unit vector. What was the definition of the unit vector? The magnitude of that vector was 1. Okay, this was the fundamental definition. The magnitude was 1. Right? So the question is, find the value of b. Find the value of this b, unknown b. Okay, give it a try, guys. Give it a try. Maybe 1. Hello, Rehana. So it's not 1, Johnny, because magnitude of A is 1, right? So, okay, hold on. Did we not cover this? Okay, so basically if a vector is given in x and y components, how do we find the magnitude of the vector? So magnitude of the vector is A, right? The x component is Ax, y component is Ay. So if I know Ax and Ay, how do we find A? Using Pythagoras theorem, right? A square is Ax square plus Ay square. So from here, magnitude of A will be root of Ax square plus Ay square, right? So if I know the components, the two components of the vector, this is how you will find the magnitude, right? So here I know the two components of the vector. So to find the magnitude, it will be magnitude of A will be root of 0.6 the whole square. This is the x component. B is the y component. So plus b square. Okay. And what is magnitude of A? It is 1 because this is a unit vector. Now square on both sides. So b square will be 1 minus 0.6 the whole square, right? 0.6 the whole square is 0.36. So b square is 0.64. Take the square root. 64 square root is 8. So 8 by 10. So this will be 0.8. So b will be 0.8. Okay. B will be 0.8. Okay, so Johnny, there what you're doing is so the thing that you're doing, right, is finding unit vector for a random vector. So if I give you A as 2i cap plus 3j cap, okay, this is a random vector, and I ask you to find the unit vector. Okay, then you will use that formula, right? 2i cap plus 3j cap divided by magnitude of 2i cap plus 3j cap, right? Magnitude of 2i cap plus 3j cap will be root of 2 square plus 3 square. So yeah, this is correct. But this question is slightly different. Here they are saying A is unit vector itself. Okay. They are saying A itself is a unit vector. So that means all you have to do is find the magnitude of A and put it equal to 1. So for magnitude of A, we will use this logic. Okay. For finding magnitude of A, we will use this logic. The x component square plus y component square under root, and we'll equate it to 1. Okay. All right. Then, so multiplication of vectors by a scalar. Okay. So basically what this is if you take any vector that you can imagine, a vector, and you multiply it with a scalar, means just number. Okay. Multiply it with a number. Then what happens? So let's say I have A here. A's magnitude is 5 units and it's in the right direction. Okay. So the idea here is simple. If I want 2A vector, this is actually 2 multiplied with A vector, right? So it's the same direction as A vector itself, but double the size. Its size will be doubled. So the only difference is here we'll have 5 units. Here the length will be 10 units. For 2A vector, the length will be 10 units. And this is your 2A vector. Okay. If it is 3A vector, it will be 15 units. And you guys get the idea. What about A by 5? If it was A by 5, it means its magnitude got shrunk by 5 times, right? So what is 5 divided by 5? 1. So A by 5 will be a vector which has 1 unit, whose length is 1 unit. Okay, in the same direction as A. So this is going to be A by 5. Okay, so this is what happens when you multiply with a positive number. So the number just scales the length of the arrow. So if you multiply with 2, it doubles the length. If you multiply with 1 by 5, it becomes 1 by 5 times. So 5 divided by 5 is 1. If you multiply it with 3, the length becomes 3 times. So that is what happens when you multiply a positive number to a vector. Okay. Now, when you multiply it with a negative number, there is also one extra point to keep in mind. Let's say I multiply with minus 3 units, minus 3 number. So how will minus 3a vector look? Okay, I want to draw that. So minus 3a vector has a length of 3 times, okay, which means its length will be 15 units. But because it is a negative vector, it will be in the opposite direction. So it will be in the left and its magnitude will be 3 times 5, which is 15 units. So its length will be 15 units. Okay, its length will be 15 units. But because this is a negative vector, negative of a means it's in the opposite direction. Okay, so if you multiply with a negative number, then the direction of the vector also reverses, and this number helps scaling the length. Okay, so if the number is 3, the length will be tripled. Everything else is the same. Okay, so this is what happens when you multiply with a scalar. Yes, direction would change. Okay, so that is what happens when you multiply a vector with a scalar. Now we'll discuss dot product. Okay, so I think this will be the last topic. We won't have enough time for cross product. Okay, so we'll discuss dot product well now. So the thing is, we learned how to add vectors and subtract vectors, right? So addition done and subtraction is also done. Subtraction was not that different. Now we get into multiplying vectors. Okay, multiplying two vectors, and there are two types of products that exist for vectors. Okay, two types of operations. First is known as the dot product. Okay, it is represented like this. So a vector dot b vector, that's how we read it. And the definition is, if you have a dot b, it's simply the modulus of a modulus of b into cos theta. Okay, here mod a is the magnitude of a vector, mod b is the magnitude of b vector, and theta is the angle between a and b. Okay, so this is the definition of how dot product is defined. Now, there's also this simple fact here. If this angle is acute, right, if the angle between the two vectors, if theta is acute, then cos theta is positive, right? If theta is acute, then cos theta is positive. Then that also means this whole thing is positive, right? Then that means a dot b is positive. A dot b is positive. And another thing, when you do a dot b, the output is a scalar or a number, right? The output is a scalar. Okay, the output is not a vector. So when you take the dot product of two vectors, the output that you get is also a scalar. This is not a vector, by the way. This is a simple number. Magnitude of a is a number, magnitude of b is a number, cos theta is also a number. So this is also a number, which is a scalar quantity. Okay, so if angle is acute, if the angle between two vectors is acute, then the dot product is positive. Okay, and if the dot product is negative, that means the angle between the two vectors is obtuse. Okay, the angle between the two, the dot product will be negative in that case. So the same thing is written over here. Now, when is the dot product maximum? So a dot b was ab cos theta, right? So when is this maximum? That's when cos theta is 1, right? Cos theta's max possible value is 1, and that happens at theta equal to 0 degree. This is when A dot B is max. A dot B is maximum value, and that is equal to simply A into B. And for minimum value, this is maximum case. For minimum value of A dot B, this happens when, what is cos theta's minimum value? It's -1, right? It's -1. So this will be minus A into B, and this happens at theta equal to 180 degree. So when the two vectors are opposite to each other, when A vector and B vector are opposite to each other, this is when dot product is minimum, and when they are parallel to each other, this means theta is 0 degree. That is when dot product is maximum. Okay. Now, so now this is actually a very important idea of dot products. Okay, it's a simple idea only. When is dot product 0? When does the dot product become 0? It becomes 0 when the cos theta term is 0, right? This happens when theta is 90 degree, which means that two vectors are perpendicular to each other. So A vector and B vector, if they are perpendicular to each other, that's when the dot product will become 0. Now in questions, they will randomly mention that A vector, there will be two vectors, and they will say that these two vectors are perpendicular to each other. Okay, and then they will ask you to find something in the question. So in those types of questions, the first idea that should come to your head is that if I take the dot product of these two vectors, it should come out to be 0. Okay, whenever you see two perpendicular vectors, their dot product must be 0. So here the thing is, we have the I, j, k unit vectors. So I and j are perpendicular to each other, right? X-axis and y-axis are perpendicular to each other. So I dot j will be 0, right? Similarly, j dot k will be 0, and k dot I will be 0 as well. Because x and y-axis are perpendicular to each other, y and z is also perpendicular, and z and x is also perpendicular to each other. So which means two perpendicular vectors, if you take their dot products, it will come out to be 0. Okay. So now so now there are some simple properties of simple formulas of dot product that could be relevant. So what is A dot A? So if you take the same vectors dot product with itself, it will be A into cos 0, right? So this is going to be A square. And so this is the first one. And what else is there? If you take A cap dot A cap, this will be, what is the magnitude of A cap? It is 1. What is the magnitude of A cap? It is 1. The angle between the same two vectors is cos 0. So this will be 1. This will be 1. Okay, and the next thing you need to remember is if A dot B is given to be 0, this has to mean A and B are perpendicular. A is perpendicular to B. A is perpendicular to B. Okay. Any other? No, that's it. So if I use this property, right? If you use this property, with this you can say I cap dot I cap is 1. It's the same as j cap dot j cap, and this is the same as k cap dot k cap. If you take the dot product with the same unit vector, this will be 1 using this logic. Okay. Cos theta is 0, yes. Okay, great. Now, yeah, so the thing is, you can also use dot product to find the angle between two vectors. This we will get into after some time. So now the thing is, if the two vectors are given in the component form, okay, if let's say two vectors are given, a vector is given as the x component, the y component j cap, and the z component. I'm also including the z as well. And there is a second vector b, which is given as the components as well, bxi plus byj plus bzk. Okay, so the vectors are given in its component form. Then if I want the a dot b in this case, if I want the a dot b in this case, so in this bracket, I'll write the three components. Okay, I have to write, I also have to write ijk, but I'm writing for short here. Okay, writing in short, and this will be bx, by, bz. This is the first vector and this is the second vector. So so here there will be 9 terms. Okay, first you have to take the dot product of ax with bx, ax I cap dot bx I cap. Then you have to take the dot product of ax I cap with by j cap. Then you have to take the dot product of ax I cap with bz k cap. Okay, so just with ax there are going to be 3 dot terms. Similarly with ay you have to take 3 dot products, and similarly with az you have to take 3 dot products. So there are going to be 9 terms in total that you get, but it is actually not 9 terms. It will simplify to 3 terms, because when you take the dot product of ax I cap, okay, when you take the dot product of this guy with by j cap, here you are essentially taking the dot product of I cap and j cap, right? This will be 0. This will be 0. Similarly, if you take the dot product of ax I cap with bz k cap, here you are taking the dot product of I cap and k cap, so this will also end up being 0. So only one survives from ax, that is the ax I cap dot bx I cap. So ax I cap, if you take the dot product with bx I cap, so here you are having an I cap dot I cap which is 1, right? So this will become ax bx. This will become ax bx. So the 2 x terms will survive, the 2 y terms will survive, and the 2 z terms will survive. So you can kind of directly write the formula for a dot b. 6 terms will become 0, and the only terms that survive is ax bx, ay by, and az bz. Okay, so this is the dot product. If they are given in their component forms, this is how you write down the dot product. So you multiply the I cap components plus multiply the y cap components plus multiply the z cap components. Okay, that's how you write the dot product. Now so we can use that in this question. Okay, so before that I can take an example also. So if a vector is given as I cap plus j cap plus 2k cap, and b vector is given as 2i cap minus 3 j cap plus 7 k cap, and the question was to find a vector dot b vector. Then try to get the answer, guys. Try to tell me the answer. Yeah. Can't we take ax, bx common and multiply with... No. So the thing is, there will be 9 terms, right? This is the first bracket, okay? And you have to take the dot product with the second bracket. Bx I cap plus by j cap plus bz k cap. So there are 3 terms here, 3 terms here. So if you multiply one by one, ax, bx, I cap dot I cap, right? Ax I cap, then you have to take the dot product with the second one. So the second one will be ax I cap dot by j cap. So here you can clean this up a little bit. You can take the ax and by outside, the constants outside, and the vector dot product is I dot j. I dot j. This will be 0. I dot j is 0 because I and j are perpendicular. Okay. So this term will die. Similarly, ax I cap dot bz k cap, that term will also die. So there will only be 3 terms that are surviving. First term is the dot product of ax I cap with bx I cap. The second term is the dot product of ay j cap with by j cap. And the third term is the dot product of az k cap with bz k cap. Only these 3 terms will survive. Because in this term we have an I cap dot I cap, which will be 1. In the second term we'll have a j cap dot j cap, which will be 1. And in the third term we have a k cap dot k cap, which will also be 1. Okay, so that was the logic. That's how we got this formula. That's how we got this formula. Okay. So it's 13. Let's see. So you just multiply the x components. So a dot b. So if you multiply the x components, it will be 2, 1 into 2. Then we have 1 into minus 3. So that will be minus 3. Then we have 2 into 7, which is plus 14. So this will be 14 minus 1, which is, yes, you guys were correct, it is 13. Okay. So this is how we take the dot product if the vectors are given in the component form. Okay. And if the magnitudes are given and the angle is also given, then use the AB cos theta formula, right? Then use the AB cos theta relation if magnitudes and the angle is given. So now we have a question here. Try to find the answer for this also. You have to find the value of A. Okay, so with this question we can end it. Give it a try, guys. So here I guess you will have 2 values of A. Okay. Here if you take the dot product, there will be 2 values of A. Okay, so we are done with dot product also. So cross product, we can probably take it in the next one. Okay, when we'll have the next one, next backlog class. So any answer, guys? So the hint given is they are perpendicular to each other. Okay, you guys keep trying. 0. 0 is not the answer, I guess. Okay. So let me explain. So here, the hint given is they are perpendicular to each other. This vector over here, P and Q are perpendicular to each other. Okay, so P is perpendicular to Q. So I just mentioned if two vectors are perpendicular, then you should think of the dot product. Okay, so if you take the dot product, what is the dot product? The dot product will be 0, right? The dot product will be 0. A square minus 2a. Yes, that is correct. So now take the dot product of these two vectors. A into a is a square. A into minus 2 is minus 2a. And 3 into minus 1 is minus 3. So this is the dot product. We will equate this to 0. Okay, this is the equation that we have to solve. This is the quadratic equation, right? So what are the roots? The roots are minus b plus minus under root b square minus 4ac. 4 3s are 12 divided by 2a. Just use the quadratic formula. This is root 16, so 4. So 1 is 2 plus 4 by 2, 1 is 2 minus 4 by 2. So 2 plus 4 by 2 will be 3, right? And 2 minus 4 is minus 2 by 2 is minus 1. Okay. So the roots are 3 and minus 1. So there are two values of a. One value is 3 and one value is minus 1. In these two cases, the vector ends up being perpendicular to each other. Okay. 3 or minus 1. Yes, that is correct. Perfect. Great. So that was it, guys. We unfortunately didn't have enough time for cross product. That we'll take up in the next lecture. Okay. So any additional doubts you guys have, or we can end the lecture here. Okay. So you guys can ask the doubts if you have any from today's lecture. So I'll share the notes with you, and in the notes I'll keep the notes for cross product also. Okay. Okay, good night, guys. Take care. I think the next backlog session will be on motion in a straight line. Okay. Motion in a straight line. Favorite movie? Johnny, I haven't watched a movie since a long time, you know. Like I'm more of an anime type of a person. You know, and like I watched Attack on Titan twice. So I think that is my favorite, Attack on Titan. Movie, I haven't watched a good movie in a long time. Okay, so good night, guys. Take care. All the best. All right. Great.